Okay, great.
Okay. Why don't we start with talking about the book? And
Yeah, but well, real quick, I wanted to tell everybody why I'm in London, England right now. I'm in the UK.
yeah.
Actually, I'm in Cambridge, the UK. So, which is about an hour outside of London. And I spoke at SQL Bits, which is the largest European SQL conference. They had about 2,000 people there. And then while I was already in the country, Crafting Bytes, which is our company,
Pete's
has.
over there. Sorry, go ahead.
That's okay. Crafting Bytes is partnered with an organization called Redgate, and they make SQL Prompt and SQL Compare and SQL Monitor are three of their probably most popular products. And I'm actually speaking at their worldwide conference tomorrow. So it's 2 a.m. in the UK. So I set my alarm to 1:30 in the morning so that I could be here for this meeting. And then I'm going to try to maybe meet right now with you guys, and maybe in 90 minutes we'll be done, maybe 2 hours we'll be done, and I'll try to get 4 hours of sleep before I have to speak to about 1,200 people at at 12:30 p.m. London time. So that's kind of a hectic schedule, but I'm excited to be here. And Scott, you just get to sleep like normal and,
Yeah.
be awake at a normal time. And
Yeah. I don't envy you.
yeah, but that's okay, because actually I really liked this book. You just asked me, let's talk about what I thought about the book. And I'll tell you one thing I didn't like is I thought after the first chapter, the book got a lot easier. And I, I'm not sure if it got a lot easier because I'm already a software developer, or if it got a lot easier because I'm already a SQL software developer. But chapters 2 through 6 are just basically are using a bastardized version of windowing functions and regular set theory in SQL, which is my native language. So, what did you think?
I didn't feel it get easier or harder. I felt it started off like in the middle. Like, I don't know, as we were going through, it's like, and here's how you do a plot and blah, 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 blah. I was like, wait. Did I miss the beginning? Did I miss the intro? Like what happened here? But other than the fact that he like hit the ground running, like just started doing, and I'm okay with that, like the concrete application. But then I kind of want to go back and like, what is the plus operator and what is it doing, and then stuff like that. I would have liked some.
Actually, you bring up a great point, Scott. What is the plus operator? I've never seen syntax like that before in any language.
It is apparently unfortunate that it's not the pipe operator.
Yeah, exactly. Even though it's less characters, exactly. Yeah, I looked that up here.
Oh.
Mike asks, what does the plus operator actually do? And from a Stack Overflow post, it basically says that ggplot2 overrides it.
Yes.
Yeah.
Oh,
and so,
thank God it override. What? That is so. All right, that makes sense. I'm like, is this an R construct? Like,
yeah,
I couldn't read
yeah,
anything.
yeah. It's not really. It's just ggplot2. And as an interesting side note, Hadley Wickham says, if I discovered the pipe earlier, there never would have been a ggplot2 because you could write ggplot graphics as, and then they use the pipe, right? The pipe character. One thing I don't like about the pipe character, I know we're jumping ahead a little bit here, is that it's so verbose.
And it's hard.
Yeah.
I mean, the plus does too, but
yeah. I would have liked it to.
I wouldn't have minded. Wait, hang on, Jim. I wouldn't have minded the verbosity of the pipe if it didn't use the percent symbol. Like, why, use any other symbol that doesn't require the shift key, then that is so ugly. It reminds me of like a HTML URL where you put a space 20. Like that that might have been a better pipe. Like,
yeah, I don't understand why they couldn't use C++'s, the greater than.
Well, yeah, that's a good question. That would have been good. Oh, I would have been that. I would have naturally typed that. That'd have been good.
I know. That felt like, because I understand that the greater than was already taken and the question mark was already taken and lots of things were already taken. So, and pipe itself was pipe itself. Oh, yeah, logical or, right? So, but I think greater than would have worked.
Yeah. So I'm sorry, Jim. Jim's trying to talk, and I keep talking over him.
Pipe greater than. Yeah, PowerShell uses that, I believe. Yeah.
For what it's worth, I think there is precedent in R for slapping percents around things.
Yeah,
so
yeah.
Like percent plus percent is a way of
Overriding.
Unary plus override. So it's sort of following convention, even if it's not.
Yeah, even if it's not nice. Yeah.
Nice. So who was that was just speaking?
Oh, Ted, by the way.
Ted.
All right, awesome, Ted. Okay, cool. So that's one thing I thought about the book. The other thing I thought about the book is he assumes a statistical background. And even when they go back and try to explain it, they just don't do a very good job of explaining it. So once again, when they're explaining statistics, I kind of got it because I happen to be simultaneously taking a statistics course. But I could see where maybe it would leave some of our readers a little confused, like why they're saying this. But so I could see where that was a little advanced. I could see where no explanation about programming constructs is a little advanced. In fact,
yeah, maybe not even advanced, just confusing, or just the no explanation of why, or
Well, they explained it a little, like on this part intro. So like before chapter 1, you have like one page.
Yeah.
Where he's like saying why visualization is a great place to start.
Yeah.
Whether or not you buy his argument.
Yeah, Jim, I think you're right, because he's like, hey, if you it's fun to see things on the screen, and if we talk about normal boring programming, you won't see anything on the screen. And I'm like, well, maybe he doesn't understand. Yeah, like he's talking to analysts, obviously. He's not, but we're programmers. We like boring programming. So we had a meetup comment where they basically said, I read the 116 pages and this is not a beginner book. And I thought about that. And I think that it actually is a beginner book. It's just not a programming beginner book. I think if you were an analyst who knew statistics, this would be very comforting to start where he started.
Yeah. Is there a more beginner book? Like, I mean, this is R for data science, not just getting started with R.
Yeah.
There is a more beginner book. You can find it on current site. It is called Intro to R. It is about 100 pages.
Yeah, so I mean that kind of makes sense.
Yeah, maybe on Meetup I'll post that link to maybe a better kind of online intro to R.
I did it, but we cannot. I'm not sure that people can reach it. I've just posted it in a conversations.
Oh, nice. Thank you. Who is that speaking, by the way? What is your name?
Maya.
Maya. Cool, Maya. Thank you. Okay. So should we just start talking about the different chapters then, so that I can go back to bed? Oh, actually, just so you know, I have a Quizlet that I've been messing around with. And Quizlet, I have 3 kids that are in school. 2 are in university and 1's in high school. And they tell me that Quizlet is the most popular flashcard application in school. So I just created a quick Quizlet with some questions. I'm not saying we have to use them today, but here, I'll put them in Hangouts, and then I'll post them in the chat window for the YouTube channel. But there's just some of the questions that we saw as exercises. I'm not sure, like, my first thought was that as we go through the book, we should review all of these exercise questions, but then they just started piling up. And I'm like, oh, we do not have time to go through all these exercises.
Yeah, I mean, like I flagged certain ones that I felt like were confusing and, you know, was easy to get the wrong answer, or maybe I got the wrong answer, and then, you know, I don't know. So we can definitely focus on those.
Okay, cool. And then the other thing in the book, they talk about RStudio, and I think RStudio is very valuable to learn as an R IDE. And I really like how the book talks about some shortcuts. And so I have been using a lot of different RStudio shortcuts, but the main problem is they don't talk about actually saving the script until well into our reading.
Yeah, we talked about that at the beginning before you joined. Yeah.
Yeah, and so go ahead.
No, go ahead.
No, so you end up like typing and then editing what you typed, and sometimes it's easy to lose your place and not really know the journey. And so I was complaining to Scott. Scott and I share an office, and so I was complaining to Scott about that. And Scott's like, "Yeah, I saw that immediately and started an Azure notebook." And so I wanted to explain a little bit about this Azure notebook for a second that you're seeing on your screen. So the first thing is Azure Notebook is free to use, so everybody can use it. The second thing is it's built on Jupyter, which is something that we talked about in our last meeting. It is an open source project that allows you to type in commands from a language and immediately save the result before you type in the next command. And so what you're, Scott, if you can scroll down like all the way down, you know, just keep kind of scrolling down. Yeah. What you're seeing here is Scott typing in commands as he reads and then seeing the results so that they work as he reads. And so basically Scott rewrote this chapter 1 using a Jupyter notebook so that we can take you on the same journey that we were on. And so what Scott and I did was we ended up sharing a Jupyter notebook as we were learning, which was kind of interesting because I was able to kind of see what Scott thought. Scott would type in his own personal notes as he read. So we've kind of been having this like online book club all throughout the month as we've been reading together and commenting together. So that makes Jupyter notebooks a lot more, in my opinion, it tells a story of the research, which is its intent. Its intent is to allow a researcher who's exploring data and asking questions to remember what questions they were asking and what results they were getting as they dove deeper into the data. Where RStudio does something similar through the script window, but you have to do the selective execution where you highlight a command and run it and see the result, and then highlight the next command and run it. You don't get to like see your results embedded the way Jupyter lets you see them. So the reason why I'm telling you this is because, one, you can use Azure Notebooks for free right now. And two, yeah, if you were frustrated with maybe losing some of your thought process as you were learning, this is an excellent way to preserve that.
Yep.
So you can also run notebooks in RStudio.
You can also run notebooks in RStudio. How do you do it?
Oh, yeah. How do you do that?
File new notebook.
Yeah.
Cool.
Oh, I guess I didn't notice that.
The reason not to use the Azure one, right? But like I was like, oh, well, this is good enough for me. You know?
Yeah. I mean, like, I think the Azure one does solve the problem of running Jupyter locally and installing other kernels.
So the RStudio one is not running Jupyter. It's running whatever, you know. And the syntax might be slightly off, but it has the advantage of being the exact same syntax that the online GitHub repository for the book has. So you can just copy the questions into it rather than rewrite them. But that's not hard. But yeah, so, you know, I was feeling the same frustration, but when I went to file new, I was like, oh, let's see what this notebook is.
Cool.
So it's mostly for writing scripts. It's not for studying.
What?
RStudio is mostly for writing scripts.
It's not for what though?
It's not for studying. You can,
Studying?
do this.
So we're saying studying? It's not for studying?
Yes, it is not full. You can do markdown. There is
Oh yeah. You can make packages and yeah, right. Yeah. Not for studying and working. Yeah.
Mm-hmm.
So the other thing is on the topic of notebooks, Scott, can you on the hip chat, can you on the hip chat, I sound like my dad or something. Can you click that link that I just sent you? And
Mm-hmm.
I did something. So because I am now an R expert, so I actually demoed it at SQL Bits as part of my session. And I did it because my session was actually on reporting on the Microsoft platform. Actually, go back, do the other link, do the Olympic link.
Mm-hmm.
So it was during the Winter Olympics last week when I gave my talk, and I was primarily speaking to Northern Europeans. And so what I did in Azure Notebooks is I uploaded a new data set for all the Olympics called that I got off of Kaggle. And just so you know, for those of you who are learning R, Kaggle is filled with data that's free. And you could find tons of different data. So signing up for that is pretty cool. And I uploaded all the Winter Olympics and I started teaching them a little bit of R in my session because I was primarily telling these Microsoft developers that R wasn't hard. And then my final thing is I took some R and put it into Power BI, and I brought it into Excel. I brought some results that I took from R into Excel and showed them Excel data too. So to teach them like, hey, you can use R to do data prep and filtering, and then use this data in other places. So the joke that I did at the end of it in Excel is I said, let's just see which country has won the most Olympic medals over time. And all the Northern Europeans were kind of looking at each other, and it was the USA. And so I'm like, oh my God, that's such a surprise. How would you have, who would have known that? Like, but I did kind of give them another backdoor because I said, well, we win in ice skating and hockey, which are primarily team sports. We're winning a lot of team medals. But if you count just individual sports, a distinct individual sports, then, you get, who you'd expect, which is Norway, right? But Canada, right? Yeah, but the USA medal count is pretty high because of hockey and ice skating, and snowboarding lately. And then the other thing is the US won the most medals in 2010. So I kind of selected that year to show because
nice.
we did pretty well that year. But anyway, it turns out the Europeans don't have much of a sense of humor. All right, let's go back and start talking about chapter 1.
So the exercises started on page 6, and the first part we were doing is basically just experimenting with ggplot and the various aesthetics. What are they called? Aesthetics that you can add on to ggplot. I don't think anything on those first exercises on page 6 were of importance. Anybody have a question about any of them, or feel like they were tricky, or anything on those guys? Looking around. Fifth. Okay, well, I definitely have some questions about chapter 3, but I think there's even some questions about page 12, later on in this chapter. So the first.
So we do have a question online, actually.
Okay.
And the question is, how do you spell Kaggle? Because I said I got some data from Kaggle, so I'm just going to put that in your hip chat.
Kaggle.com.
Yep.
So kind of just like you'd expect.
Really? It's a weird
Yeah.
word. What, you know? Yeah.
It has too many vowels, in my opinion.
Has too many what?
Vowels.
Vowels. Kaggle.
It should be KGGL.
Yeah, of course. Yeah. The Web 2.0e. Yeah.
Yeah, that would have been good. Yeah. Okay, and the other that,
Sorry, go ahead.
although I will say on page 7 where he says an aesthetic is a visual property of the object in your plot. Aesthetics include things like size, shape, and color of your points. I was like, what a weird, that's just kind of weird. I wouldn't have thought to have described it that way. And luckily, immediately he starts showing what an aesthetic is. I'm like, okay, that made a lot more sense.
Yeah.
So at some point, he says that ggplot is like implementing some domain-specific language for graphics. Right?
Yeah. It's at the very end of this chapter, I think.
Yeah. So I think that's where some of the technology is.
Yeah. The layer.
Geom.
Yeah.
Yeah, I will say that layering thing that he started doing toward the end of the chapter, where he was like, look, we're going to overlay plots and we're going to smooth them out and we're going to show confidence level. I was like, holy smokes, this is powerful. This is a lot more control. Like if I had to make something like this in Excel, I could maybe get 2 layers, but he's demoing like you can have 3, 4 layers of things. And I thought this is amazing.
So my first question that I had, he was asking, are the variables categorical or continuous?
Yeah, that's a good question because that's a statistical question, right?
Yeah.
So
cylinder was the one that I had issues with.
Oh, because okay, that's a good question. So for those with not a statistic background, categorical is basically a discrete set of numbers that are integers that are known quantities with a finite number of results. And continuous are basically an infinite number of results that you can get. And so certain visualizations are good for categorical data and certain visualizations are good for continuous data. And it's important to know what the data is before you choose the visualization. So I don't know, is that a good explanation?
Yeah,
It's a good explanation, but I think we can still quibble about this MPG table, right?
Yeah.
I mean,
okay, yeah, let's quibble about that.
So year, I would say is categorical in the context of a car, right?
Yep. And so would be like make would be categorical, right? No, year is definitely categorical because you know the range of years they've been making cars.
This is a 1995.13.
I mean, there's always going to be a limit based on your data.
Well, so this is, yeah. So
you're always going to have a min and a max.
So as far as our studio goes, I don't know about Jupyter, it is what's driving this is data type, right? So it's considering year to be a continuous variable because it's stored as an int. If it stored it as a character string, it would recognize it.
But cylinder is stored as an int.
Shouldn't be.
I know.
No.
You see the order, and also there is a way to order categorical values in R, but I guess he didn't want to go into it.
Well, I'm just saying, like.
Oh wait, let her talk. That was interesting.
She finished.
What?
Yeah, finish that thought. Yeah.
No, she did. She finished.
I said we have special object in R, which is called factor. We can.
Which is like enum in other languages.
Yes, it's kind of like enum, and it enumerates classes, and by default these classes are not ordered. So if, for example, you apply to it linear regression, then this variable will be a source of a number of dummy variables. Will be created into dummy variables. Yes.
So.
And it is very convenient. There are many functions in R which uses this factor. Yes, when you have a factor inside of a data frame, it is very convenient. One column can be, declared a factor, and then you know that it is a categorical variables, and usually by default they are unordered. but you can order them if you wish.
Yeah.
It is
You were
just
going to say, Ted?
additional step.
Actually,
So-
I'm grateful she's here. I'm grateful Maya's here. Thanks, Maya.
Go ahead, Ted.
So when you're talking about data, there's different levels of information that can be in the data. So at the one extreme, you can have unordered categorical data, and that one no one's going to argue about, right? You know, apple, orange, banana, like just no, whatever, right? And then at the other extreme, if you have data that not only is ordered, but that math makes sense on it. So like an 8-cylinder car has twice as many cylinders as a 4-cylinder.
Yes.
Now, I could argue that we're probably not going to do math on the number of cylinders in this data, but in theory, like Maya was saying, if you did a linear regression, you could actually treat it as a continuous number, and you could try to see if there's some mathematical function that relates to the number of cylinders by doing math on it, right?
I have friends in El Cajon that would treat the number of cylinders in a car as continuous.
But so your example here is where it gets gray, because you don't necessarily care if a model is 3 years later versus 1 year later, just as long as they're different years, right?
Yeah.
Oh, right.
As a continuous evolution of whatever. So I would agree
It
that you
depends,
could
right? It depends on the question you're asking. Right?
exactly, right?
Because there is some data in those years, which is that changes in technology over the years. So
Right.
the greater than less thing does matter.
Yeah, and you could arguably look at something and say if it's 5 years newer, then you expect more fuel economy than something's 2 years newer. But at the end of the day, that's the difference between having something that's categorical versus continuous, is whether or not you're going to apply math to it. If you say something is twice the distance from something else, does that mean something?
Yeah.
You know?
Oh, thanks, Ted. I appreciate that.
So what you're telling me is my answer is, what the heck did I just do? Oh, my answer was correct. The cylinder is continuous, although technically limited.
If you think of it as a number that you could
Cool.
do math on,
Yeah.
then it's continuous with just very few, like
Yeah.
you said, limit, very few examples.
Yeah.
But-
Cool. All right. That answers that. Anybody else have any other questions on this particular set of exercises on page 12? One thing I didn't like is that it was just like exercises. There was no way to refer to the exercises other than by page number. And I was worried that my page number would be different if someone was using like a Kindle version or something like that, you know? So that was just a editorial comment.
The online version of the book has numbers.
Aha.
3.5.1 and stuff like that.
Actually,
Gotcha.
Scott,
Yeah.
my complaint is I bought the Kindle version of the book and was reading it and highlighting it, right? And you were using the paper version of the book. And I thought, oh, that's kind of new technology. I've never seen a paper book. And so I bought that, and the print. So in the Kindle version of the book, these visualizations show up really well. And in the print version of the book, some of them don't actually show up that well. Some of them look kind of like ink blots, or he goes to one screen where there's Venn diagrams and it just looks like 6 circles that are, it looks like, 12 circles that don't have any distinction when he's showing like set operations of joining unique sets. And in the Kindle version, those Venn diagrams show up. You can read those. But I was like, what did O'Reilly, are they using like some type of like, low budget, printer now? I don't know, but
I mean, who knows? Because like on the opposite page of that, they're using all kinds of color and stuff.
Yeah, I know. It was weird. It looked like some of them were well done and some of them were very poorly done, and I couldn't tell. I mean, maybe it's just an editorial. I mean, like editing. It was an editing oversight.
Yeah.
Like,
so something like that's probably likely, because like in the preface, he talks about how they generate the book from code.
Oh, right.
So probably just no one noticed that these were not coming across the PDF or whatever they sent to O'Reilly.
Yeah, exactly.
Oh, right. Whatever they sent to O'Reilly, right?
They had the wrong.
Yeah. The wrong chart. Yeah,
One-
it was
one-
talking
That's
about
a
one of
repeat
them.
The one on page 8. And
Yeah.
what it actually means.
Yeah,
that was-
exactly.
When that question number 3, where it says, you know, what's, or maybe it was 2, how many rows and columns are in NT?
Yeah.
But in the book it says NT cars. At least
Yeah.
that was corrected online too.
So did you see, Jim, did you look at the meetup and see my link? Because I actually found a link with all the answers to the exercise questions, which to me, it was really helpful because sometimes I'm like, I have no idea what this answer is or what they're driving at. And then the guy online who answered the questions would say things like, you probably have no idea what he's driving at because he didn't really talk about this specifically, but this is what he means, you know, like, oh, thank you.
I Googled around and found one set of answers because I was stuck in the middle of chapter 3 on the one where he said recreate this plot using a geom instead of a stat.
Oh yeah, that was hard for us too. Scott and I were talking about that.
Look at the thing and figure out what the default geom is. And the help file for that thing was like if you scroll down to geom, it talks about histogram and frequency poly. Apparently what he was meaning to say is like in the 2 usage examples, it says the default geom for the actual function call equals point range, which of course is not mentioned anywhere else.
Oh yeah. I did note that.
Yeah.
What is that? Oh, that's in chapter 3, you said?
Yeah, let's maybe we'll talk about that when we get there.
Oh, okay.
Yeah, that kind of it was a big time suck. So that's why I finally Googled around to see what the hell was going on. Because trying to make that graph with a histogram just does not work.
Yeah. So true.
Okay, so what page are we on for people following along on that?
I guess 20 then.
Okay, 20. Cool.
In 20, he introduces the freak poly that Jim was just talking about, the box plot, histograms, area charts, all in those. Oh, here we go. Here's one that, what does show legend false do and what happens if you remove it? And I ran them, and there's the 2 graphs. Which one has true and which one has false?
Yeah.
Like, can't tell. I mean, show legend, obviously it should be showing legend true here, but isn't. Or it should remove these 2. I mean, like legend should be the thing over here, right? And it's just not.
Take the argument on the one where it's
true. Yeah.
Just take away the show legend equals.
Still nothing. Yeah. Anyway,
Maybe
so
that was the point of the question, just so that you know.
yeah, exactly. It was a trick question. Let's see. Will these 2 graphs look different? So I hate how, you know, it took him a long time to introduce the fact that we could have typed a lot less, you know, like page 20, you know, that would have been something I would have mentioned way up front, you know, like here's the verbose and it's really cool for explaining things. But now if you're trying to type it along, let's use the, you know, the ones without all the equals.
You mean Qplot?
I'm sorry?
You mean Qplot? Quickplot?
In the no, I don't know what you're referencing. I was just talking, and yeah, in the ggplot, you know, and the AESs and the geoms and so forth. You know, he was explicitly saying data equal, mapping equal, x equal, y equal, etc. And so when I was following along, I was also typing all of that extra stuff. And then finally he introduced, you know, on page 20 or so, you know, hey, you know, you can actually type it without all that extra stuff. So it made it much easier to type from that point on.
The other thing, going back a little bit, like page 15, I really liked Facet Wrap and Facet Grid, only because, you know, my primary tool that I use for reporting is either Excel or SSRS or Power BI. And this thing is very difficult to do in Excel and Power BI. but very, very easy to do in R. So that was, I thought, wow, that is very nice. That's going to get some use.
Yeah. He does ask what the advantages and disadvantages are. The advantage is that it, separates them out, so you're not confused by the other values. And the disadvantage is, they are separate, so it's harder to put them together visually and see how they relate, right? So,
when they're together, right, they could also be over plotting, right?
Yeah.
So you may not know that like compact and mid-size like
share a lot right there.
Blue,
Yeah.
The blue one on top, you wouldn't know that compact would be small.
Right. Exactly. Yeah.
Yeah, that was awesome.
Okay.
Okay, so if you're following along, we're on page 22.
Yes.
Yeah, I can't remember if he talks about it, but probably no surprise that if you are doing like a facet wrap, you can filter on which ones you want. So like if you didn't want all 7, you just wanted 3 particular types of cars.
Oh, that's interesting. Yeah, I don't think he did talk about that, or at least not that I remember.
But so I mean, that's to me, like what.
Oh yeah.
Like, doing that in Excel is just a pain in the neck, and you just create 3 separate ones yourself, or whatever, to have this. But sometimes you just don't want all 7.
Yeah.
I wanted these 2 or whatever, and so it's nice that you actually can do it from that.
Yeah.
There was that other cool one which may have come earlier, where like he did an expression, and n less than 5 or something like that.
Oh yeah, I saw that.
Yeah, and I don't think it was for faceting, but that was also cool to see. Like, I think it was a very early one because it just divided the graph in like half by like cylinders or something like that.
Mm-hmm. I remember what you're talking about, although I don't remember exactly where it was. Okay, and so then we moved on to.
By the way, to reinforce your original thing, Scott, where you said we started off with visualization that was hard. So I'm in the conference last, I was speaking on Saturday, and I was showing R, and I basically showed like, hey, what do you think this does? And I showed like load.csv, and everybody in the audience, there's 120 people there. They're like, it loads a CSV into memory. I'm like, yay. Okay, now then I showed like filter, which we learned about in a later chapter, right? And what do you think this does? And they're like, that's a where clause. And I'm like, yay. And then I showed group by. I'm like, what do you think this does? And they're like, that's grouping and aggregation. Yay. And then I showed ggplot, dead silent. They're like, no idea what that does.
Yeah. And this part, I think, was one of the most confusing parts to me, is the fact that you can use the statistics or the geometries interchangeably with one another, because as he says, and this I even wrote down, I didn't write down many notes. I did mostly just the exercises, but I did write down every geom has a default statistic and every statistic has a default geometry, right? So that I felt was helpful to know, and also confusing because it's hidden a little bit. Yeah. I felt it was kind of interesting that you can do the same thing with, geom bar and stat count. Here's your question, Jim. I think this is the one you were talking about, or was it you? That was with the point range, or yeah.
Diamonds cut versus depth.
Yeah. And so he asks, what is the default geometry associated with stat summary? And I wrote down answer. Well, stat summary says geom histogram or geom freak poly, but it looks like point range to me. So that's, and I even like verified that, here's stat summary and here's point range, and look, they're identical. Yeah. So it must have been hidden in the help somewhere. You said you found it eventually.
Yeah, so
hey guys.
Yep.
When it shows the it's like description then usage, and it shows like mapping default equals null, data default equals null, geom default equals point range. But again, if you look at the arguments where it's like giving you the narrative of the arguments, it doesn't
match. Yeah. Ike, you were going to say something?
Yes, I did. Greg Friedman is typing so Greg didn't join us in person, I guess.
Nope.
And
tell me he's a bastard.
Yeah, I think you did that very well just now. Okay, so Greg says he has a question on page 18, and so go ahead, Greg.
Page 18.
It's kind of an inefficient way of communicating, I guess. But
well, when he has it, interrupt again.
Okay, that sounds good. The other thing is somebody asked about the link for the answers, which maybe not everybody saw. So I'm going to go ahead and put that in the hip chat in case people there want to see it, and then I'll go ahead and post it in YouTube. Oh, here he is. He's here. He's like, the first uses GeoSmooth, and the second uses GeoSmooth with group.
Mm-hmm. Yeah.
Okay. So I'm not sure what his question is yet.
Okay. Still typing.
Okay.
Yeah. I did see these. Yeah. Yeah.
Okay. My other thought while Greg's typing is Jim, Ted, you and I are having a great conversation, but it might be a little bit advanced for, like, is there anybody else in the room that had any questions? I wanted to make sure that they had a chance to speak.
We're checking.
Oh, you are? All right, good. Okay, so Greg finally says on page 18, having trouble wrapping my head around why the first curve doesn't seem to include the values from the grouped one.
Where is the answers I published? I saw them on the meetup.
It is on the meetup. It was in a discussion forum or something, right, Ike?
Yep.
Where the answers are published. Yeah, but it's right here on my screen. So it's like from the University of Chicago. R4DS_solutions.
So I understand what you're saying, Greg. So Greg is looking on page 18 and page 19, and I think what he's asking is, when you use GeoPoint, you get a lot of data, and when you use GeoSmooth, it smooths it out and doesn't seem to appear what's happening. And this is just a common thing to do in statistical visualization to show what you're seeing is an overall mean of the value in that coordinate that smooths it out so that the trend is easier to watch. Maybe that's his question. I don't know.
Well, no, or maybe,
or maybe but, when you group.
So in the first graph, this is the line showing all of the data points. In the second graph, there are 3 different lines corresponding to the 3 different groups of
which is whether it's 2-wheel drive, 4-wheel drive,
or
front wheel or rear wheel.
Yeah. So if you basically combine those two, or those 3, sorry, apparently you would end up with the first graph.
Yeah, I think that's true. Yep, that makes sense to me. Hopefully that makes sense to Greg.
Okay.
All right, keep going.
All righty. Okay, so where were we? We were on, we did Jim's question. This one, I had to guess, so this is a good one to talk about. He asked, in our proportion bar chart, this is question number 5 on page 26. In our proportion bar chart, we need to set group equal to 1. Why? In other words, what's the problem with these 2 graphs? And I ran those 2 graphs, and they look like this. So it's clear that those are not very helpful. And if you set group equal to 1, it does show. And so my show correctly, I guess, proportionally. And so my guess was the proportion of each category is 1. So that's what we're seeing here. But grouped, they have the total proportion of everything. And so it's basically showing the proportion that each category has within the whole rather than within itself. But I felt like that was kind of a weird default, like that it shows the proportion within itself, like as the default. And only if you say group equal 1, does it do the right thing. I felt like that was just bizarre, but that was my guess. And that's.
I feel like Ted knows the answer of why it does that.
Well, I think if you're doing a pie chart, you might find the not needing the group is more.
Got it. But with the bar chart.
Yeah, totally.
Yeah. Okay.
And also, I'm not even sure, but I think group equals 1 is like a fake variable just to get them all. It's not like meaningful. I found that to be confusing.
So you're saying if I said group equal 2,
group equals foo, group equals anything. Just
all right, let's check it out.
Here we go.
Totally.
Now you're seeing the value of the notebook. Oh, he's right.
Yeah. Does not matter. 1 hill of beans. Yep.
Doesn't matter.
It's the whatever, lazy evaluation. It's basically just treating it as a brand new variable, and it doesn't matter what it is. It just so everything gets
Group equals 0.
Yeah, group equals 0.
Right.
I don't know if you could get away with like a null or an NA, but pretty much anything will.
I will say, I bought the book. When he switched the data set to diamonds, I just lost interest. I was like, can we go back to cars? This is boring. I don't care about this.
But I did love the flights.
I did too.
Yeah. I felt the same way. I was like, okay, cars were cool. Diamonds were kind of but then flights were like, oh, this is awesome. So much data.
Yeah.
Yep. Okay. So then we started talking about position adjustments. And we have exercises on 31, which weren't very many, and I don't think there was anything crazy in there. Geom count, and then there's the box plot. Yeah, nothing really exceptional there, I don't think. Okay. And then he ends the chapter talking about coordinate systems and the layered grammar of graphics.
Yeah, I will say on page 31 when he's like, coordinate systems are probably the most complicated part of ggplot2. I'm like, oh, really? That's exciting.
Yeah. Like, yeah, I see what you're saying.
But I didn't know what those meant until he started showing it, and then it was just typical geometry and geospatial data. And yeah, that is the most complicated part of anything. Like not like if I showed you how to do that in SQL Server, or I showed you how to do that in any language, it's complicated pretty quickly.
Yeah. All right, and then so we had
geospatial data.
Yep. Page 33, there were some exercises, and this one actually,
Scott,
yeah.
can you crank up the zoom on that? You got some gray space up there.
Gray space. Yeah, I can. Oops. Yeah. So this question about the stacked bar chart into a pie chart, I will say I struggled quite. I probably spent 40 minutes on this freaking question, trying to get this to look right. And I still don't know that I did it correctly, but here's another one of these x equals factor 1. Like, I think that's what you're talking about. Like, it's like a placeholder just saying there's only one group of these things. And I tried, and I still, yeah, it's with diamonds, I couldn't get it to work at all. here, let me comment this one out, and this one, I would end up getting something that was like totally bizarre. Like, yeah, that thing.
That's
It's like,
beautiful.
what
I
in
really
the
like that. That is
effing
great.
hell is that? I mean, like, come on. What? Why? I can't. I don't even understand it. Right? It's bizarre. Anyway.
You fucked up in a spectacular way. Like,
I like the coxcomb chart. It wasn't one of the exercises, but it was on the page right before that. It was the diamonds. It's like a pie chart, but like it doesn't make a real pie.
Oh yeah. And that's the thing it sort of does by default, or and I was trying to make it look like a real pie chart, and it took me a long time to be able to get it, and it's only with certain. I don't know. It was very difficult. Oh yeah, that was probably it. Yeah. It's some hidden argument that doesn't actually do. Yeah, so it was basically this chord polar theta equals y thing that was and I had to Google the crap out of that in like 100 different ways to find that out.
I love it.
Yeah. Okay, cool.
so then you got to page 34, and this is what Jim was talking about, the layered grammar of graphics.
Yeah.
And I remember getting to this point thinking, well, I'd like to hear the grammar. Like, did he just explain all the grammar? I mean, is this comprehensive, or do I sound like an idiot if I start talking about this now? Like, I feel like we got a small subset of the overall grammar of graphics, but maybe we didn't. I don't know.
Well, I think he was using it as a summary, basically saying if you have data, geometry functions, mapping, statistics, positions, coordinate functions, and facet functions, you have covered every graph ever created by man.
Okay, all right. Well, let's talk about that for a second. Okay, hang on. Let's talk about that, because I want to. I guess I didn't spend any time thinking about that to know if that was true. But on the third paragraph of page 34, he said the grammar of graphics is based on the insight that you can uniquely describe any plot as a combination of a data set. So what's a data set? It's the MPG, the actual data that we load in, right? A geom, which is what? Either a scatter chart or a line or a bar chart.
Yeah. Type of plot.
Type of plot. A set of mappings, which is we want the X and Y coordinate to be this, or we want, right?
Uh-huh.
A stat.
Which is like how we want to summarize, or how we want to,
whether it's an average or a sum or a median or something.
Yeah, exactly.
Or just a raw value.
Yeah. Or sometimes
is it a variable? Is it a variable in the data set?
I
think a stat might be. I think a stat is
it's a transformation. It's a transformation, right? But you can use like an identity transformation, I assume, in which case you just have a variable, right? Like
I don't think it is a transformation. I think a stat is basically in a tableized data. It's a column. It's some type of observation about the row.
Yeah, but you're producing a column based on its input value. It's true that it's a table in, table out, but those two tables don't have to be the same. Therefore, it's a transformation.
Yeah, page 22 seems to support your argument there, Scott.
Okay.
Jim says page 22 supports my argument.
Well, since Jim's always right, I guess we'll go with that. Okay. So, and then a position adjustment. And I'm not sure I knew what that was entirely, but
maybe
hold on.
just like jitter, or was that the position adjustment?
Oh yeah, like dodge, or count, like the ones where they blew up the size of the point, or jitter. Yeah, those things.
Okay. And then a coordinate system, which makes sense because I think that they're talking about scale, right?
Mm-hmm.
And then a faceting scheme, which is the grid or the wrap, or
So I mean, you don't have to have a facet function. Just like you can use,
Yeah. well,
your
rotation-
statistic function doesn't have to actually do transforms, but
So Cartesian, I think, is the fault, right? And
Yeah.
then
You know, one thing
polar or
I
geo.
found on page 18 was the cheat sheet,
oh yeah.
and I printed that out. And the 2 pages of the cheat sheet to me explain 100 pages.
Yes.
Because it's
Agreed.
that layering description
Yes.
on the left, that then all of a sudden I clued in, oh, that's what we're doing, is just layering on top.
Yep.
And
Okay,
then
actually bring
graph-
that up on your screen. Bring that URL up on your screen, because when I underlined this and I actually tweeted it. I don't think I put it in the meetup discussion, but I tweeted it and I said, I think we should print these out and put these on our wall, Scott. Like, we should like Crafting Bright's brand cheat sheets and give them away as posters or something.
Markdown, shiny, there.
Yeah. And that left-hand column, you know, a little more than halfway down, explains
Can I not?
ggplot does.
Okay.
Also,
Who is that speaking
I
like?
did.
I should have looked at that.
Yeah, this.
Took me 80
Yeah.
pages, but, you know.
Oh, I want to know your name.
Oh, Russ.
Ross. Okay, yeah, Ross is right.
Ross.
And I'm going to repeat what Ross said for the online viewers. Ross said on page 18, there's a URL in the second paragraph for cheat sheets, which Scott just brought up. And he said using that cheat sheet and then reading gave him context to what he was doing. And I can absolutely see where that would help.
Okay, here we go. Yeah. What helped me was the later on when we were doing some, like, it was in chapter 3 or 5, I think, and it was like, compare this variable with that variable, or, you know, whatever. And I was like, okay, so this one's discrete and this one's continuous. So I need to use something from this category in order to compare them, right? Or, ooh, those are both continuous variables. So this is the, you know, the stuff that I can use, right? Anyway, that was one of the aspects of the cheat sheet that helps me. But yeah, the whole thing was very, very helpful.
That is really helpful. Look at that cheat sheet, say faceting. See, I wish Ross would have been around earlier in the month.
Russ
Russ.
with a U.
All right.
Both of them even, you know, Ross and
Oh, yeah.
Okay, so I think we spent an hour talking about graphics, and I think that was appropriate, at least for me. Well, maybe not for everybody, because the rest of this I could have probably figured out just by reading code, right? Like, I'm not sure I learned as much on the rest of the chapters, except I did learn a lot of our studio shortcuts, but
Yeah, I think to the point about the cheat sheet, like substituting for like 100 pages, because I was like, wow, I'm getting through this real fast, because like every single thing was like, here's another function, it does X, and then just kind of scan to the next one, here's another function, it does Y. You know, I'm just like, okay, great. If I ever need a reference, I can look at this, but I wasn't really reading it.
Yeah. Well, I was reading it because, you know, I was doing the exercises, and the exercises were very time consuming.
Yeah.
It took me a long time to get through the whole of it.
so in chapter 30, or on page 38, he says, what's in a name? I did want to make a point to the developers in the room about naming. And that is, if a lot of you are traditional transactional developers and you name things, you typically name things for brevity because you know you're going to have to reference it a lot. But in business intelligence, almost universally, we don't name things for brevity because brevity, you really lose track of context and exactly what you're talking about. And in fact, in business intelligence, we don't even use acronyms, and we don't really shorthand anything if we can avoid it. And the reason for that is because a lot of our code eventually surfaces up into a visualization that a CEO will look at. And CEOs are not known for their ability to read programming languages. So, you know, we have to say something clearly what this is, because the CEO has a frame of reference on what that is. They have their own vernacular, and if we confuse them, they get super angry about it. So you tend to be less terse, right? You tend to explain
there
what
was
you're
actually that brings up a good point, Ike, on page 33. I mean, it happened over and over again in the book where I would make a mark. I'm like, God, why couldn't they have written this out? Why couldn't they have added the extra letter? You know, but the worst one was labs. Was on page 33. What does labs do? Oh, that's labels. They couldn't afford EL.
Oh yeah, yeah.
They were, you know, they couldn't afford to buy a vowel, right? So they had to be stuck with labs. And so everybody's like, what does labs do? I don't know, like, you know, pharmaceutical labs, or we're running some sort of experiments on this thing. No, it's labels.
Yeah, it's ridiculous.
Oh,
yeah.
God, that's stupid.
So anyway, my 2 cents about adding names is avoid using even acronyms that are, like YTD for year to date is probably fine, but beyond that, you should think twice about it.
Ted.
Sorry, one last thing just about the ggplot stuff. So we got all the way to page 32, and at the bottom there, the code, I noticed, hey, he did a ggplot and assigned it to a variable.
Yeah.
And I was looking some stuff up for work, and found a page, and they were doing the same thing where they assigned the plot to variables. And anyway, so I'm like one who often tinkers with the chart. I'm like, yeah, this is exactly what I want. And but I also don't like copying and pasting lots of lines, even though it's not that hard. But so then I was like, oh, this is really useful, because if I'm going to just like keep the same first 4 or 5 lines with all those overloaded
the
pluses,
mappings and the whatever,
assign that to a variable, and then I can add one little plus with this thing, and what if I change this, and just for me that was really convenient. And I wish I had.
Well, he says that as a way of programming later. He says you could do it this way, or you could use the pipe operator, and obviously pipe is easier to read. And I'm like, is it? Is it easy? I'm not sure that's true, but I prefer, like you just said, having the intermediary step of having a variable that you can play with and play with it 100 different ways before you go to the next command. But anyway.
Well, I mean, I think it's just really weird that like he's not talking about notebooks at all. Like, because RStudio supports them, because the book itself is a notebook, right? I mean, so it's like really weird to me, because again, like some of those things could have been, okay, put this in your cell, now do this with that variable that you defined. And he could have eased into like the programming concepts a little bit more smoothly.
Yeah, I'm with you on that.
The author.
Yeah.
So I guess we presume he knows about the features of RStudio.
Yeah. Okay, so moving on to 3. I don't think we're gonna finish, but maybe we'll. I don't know what the plan is here, but the one thing I looked up right from the get-go is how the heck do you say this thing? And apparently it's deplier.
Depliers?
Yeah, depliers. Yeah, exactly. Give me deplier. That's sort of an implied S.
Deplier. I thought it was Dippler.
No, deplier.
I always read everything wrong in my head. You know how I was listening to Harry Potter audio before the movies came out, and it was Hermione? I was like, what? I read everything wrong.
I think everybody did that, Ike. So it stands for the data frame applier.
Oh, the data frame applier. Oh.
Yeah. Speaking of, as Jim said, buying a vowel or whatever, like putting an extra constant. Yeah.
That makes sense.
Anyway, so I thought that was kind of interesting.
Yeah. Wait, you know what? Now that you're talking about buying a vowel, I can see that it bothered me that DTTM was date time. I'm like, now I see DTTM. I've got to translate that to date time. What is it in T-SQL? It's date time. What is it in C#? Date time. What's it in JavaScript? What's it in R? DTTM. Oh, that somehow I'll remember that. But
speaking of comparisons of the language, my 3 most known languages are Python, C#, and JavaScript. And so I just sort of did a compare of the R operators that we're learning in this deploy R chapter with the various transforms that are found in Python or C# or JavaScript.
Only you would
And
do
I
this,
thought it was
Scott.
pretty cool.
Oh,
What?
Only you would do this, Scott. He's like, oh, what operators? Let's do an operator comparison. That is
Yeah.
really funny.
So filter seems to be the consensus. Like everybody uses filter, so that was cool. And that was backed up by what you said at the crowd at SQLBits, because like filter, oh yeah, that's aware. Everybody knows that's aware. But everybody has a different way of sorting. JavaScript's, I put a little asterisk there because that's the worst, because it doesn't actually, it sorts in place, which is hideous. Anyway, but and then apparently it's either select or map. You know, those are your two choices for how you project. And then it's also interesting that in C# and JavaScript, you can select or map out more things than you were given in. And that's also true in Python. I put the P there. That's from Pandas. That's the one that I've used the most. But there are other ways of doing it in Python depending on the library that you're in. But then in R, it's mutate. And I read somewhere that mutate was going away, that it was going to be obsoleted. Did anybody else come across that, or was that a dream? No. Yeah, because I feel like
Scott's
kind of like the way that
but
I feel like that's kind of nice about C# and JavaScript. You have a way of projecting, you know, just a subset or projecting something bigger than you created, you know, that you're given, right? And it really shouldn't matter which one, you know, which direction you're going. So to have a different keyword for it is kind of weird. In fact, you can also use map in Python. Go ahead, Mike.
Chrisbert Online says, view is a great way to be able to see the data. Is this the only way of seeing it? On page 44, where he said, like, view flights, which will open up the data set in RStudio Viewer. It prints differently. It's a tibble. Tibbles are data frames, but slightly tweaked to work better in the tidyverse. I think it is the only way.
Because I did not, I wasn't in RStudio, as you know.
Right.
Who else was in RStudio?
I used head and summary.
Yeah.
You can use summary.
I definitely use that
Yeah.
all over the place.
You can do like
Head.
100 or head
Yeah.
10. You can see the first 10.
RStudio has a GUI where it's like pulls up an Excel spreadsheet view and you can see the whole thing.
Yes.
Like not in a character textual thing, but like, you know, like a spreadsheet.
Yeah, and I noticed on the right, you know, if you had a data frame or something, you can click on it and it actually will show all the columns too. So if you're looking at something with a lot of columns, it's easy to see.
Yeah, the RStudio IDE has a lot of bells and whistles on top of just the raw R language.
It really does. And when I was in Jupyter, on that note, when I switched to Jupyter to hang out with Scott, I was frustrated because I had taught myself the RStudio shortcuts, which made coding a dream and navigating a dream. And then you're just hamstrung in the notebook where you can't do that stuff. But
well, I mean, you could do like, you know, when I'm working on like a web project where I have like JavaScript on the front end and some other language in the back end, I'll bring up two IDEs. All right, so you can have RStudio and the notebook, and you know, you could just be taking what you've messed with in RStudio and paste it into your notebook for posterity's sake. You know, kind of, you know, kind of like a pre-check or whatever. I don't know.
Hey, Scott, can I make a quick note about tidy conventions before we get too deep into the deployer? So one of the things, if you look at the standard R documentation, is that you never really are allowed to just name the column. You always have to say the data set and then something, $$ or whatever, to indicate where that column is coming from. So a big part of why some people are super loyal to Tidy is because generally all the Tidy packages don't require you to do that. So the idea is you're working on one data set at a time, and it's implied that any column you're going to pull is from that. So therefore, we'll just skip that, all that extra typing and the $sign or the brackets or the whatever. But just remember that you're reading this, and then you read somebody else's code, or you go to basic R, or somebody who's not following Tidy conventions, you're going to see a lot of that verbosity where it's data set $column name, data set square bracket.
Yeah.
You can attach a data frame and skip it. There is a command to use attach.
Yes.
But
yes.
Maya needs to speak up because you can't hear her on the YouTube channel when she.
I said that there is a command for attach, by which you can attach a data set and you can use its column as a variables in the environment.
One of the things actually I reacted to pretty quickly in R, I'm like, God, there's no dots, you know, like there's no namespaces or anything. And then I looked that up and it's like, oh, everything's a global. Oh, okay. Well, then, you know, I guess you don't need to worry about that.
One of the things I liked right off the bat was the concept of the tidyverse in general. Like it hit me as like a distribution, right? Like this is something I've been saying that JavaScript needs forever, right? I'm like, instead of going out and picking a million random packages, just say tidyverse for JavaScript, and then here's, you know, Angularverse or Reactverse, and just So
or you know, like Anaconda or whatever for Anaconda's for Python, right? Yeah, you need a well-known, agreed upon set of libraries that everyone uses, rather than the effing chaos.
But not everyone has to use, like,
right.
You can choose to join that group and use that distro. Just like
I will say that in Power BI, so Power BI has two different components. It has a desktop component and a portal component. And the libraries that are available to you in the portal, there's about 30 different packages that you can use, but you can't use Tidyverse. And I'm like, is Tidyverse just not ubiquitous the way I think it is, the way the book is outlining that it is? So I did some research and I'm like, no, it is. Microsoft just decided not to use it. Like, I'm like, I wonder why they made that choice. Like, didn't make any sense to me, but.
Yeah, cool. So for this part,
do they like data table?
Oh, what do they use instead, Ike?
Yes.
They have a list, and I don't know R well enough to know what they replaced it with, because once I didn't have Tidyverse, I just zoned out. I was just like, I'm not going to use it in the portal yet until I learn more R, so that I can write something that's not using it. Yeah.
So for this part, you were talking, Russ, about the summarize or the head, or, you know, whatever. When I was going through in Jupyter, I noticed after I ran about 300 or 400 of these that it started getting a little sluggish. And so I went back through and I was like, summarize or whatever, you know, or count or head or whatever, to like kind of trim the result sets down. And then it was like, oh, okay, so much better again. Yeah. It is, especially for these flight data that has, you know, some of these things have, you know, here's one with 139,000, you know, rows. And there were some with more because they were like Cartesian product type things, you know, where it was multiplying the two.
What page are you on, Scott?
The beginning of Deployer, the first set of exercises for Deployer, 49.
Got it. Okay.
Or they start on 49. And I was kind of hoping to double check my work, but I can use the answers that Ike sent around, I guess. Wait, is this the one? No, it's in here. Data transformation. Oh, except for he doesn't put how many rows he has either. Oh, wait, there it is. Yeah, 10,200 is what he said. Let me get these out and docked. And let's see if I can. Uh-oh, did I lose you?
No, but it turns out it's okay. I thought you're going to dock things. It's going to go small, but no, I can read it.
Okay. So 10,200. All right, cool. And then 9,000, good. And then 139,504, good. And then 86,000, good. And then 29, good. And then, aha! Interesting. Delayed departing at least an hour, but made up over 30 minutes in flight.
He does greater than or equal to. It's a boundary problem. He does greater than or equal to. You did greater than.
Yep. Over 30 minutes. Okay. So I am right. He is wrong.
Yeah.
Okay, cool. And then we've got 9,003. Oh, did another difference. Jesus, probably the same thing. Oh, no. This one I noticed, and apparently he did not. I was looking at the data, and I saw a 2400. I'm like, what the is that? 2400, that hour doesn't exist. And so, what?
Do you have it in data?
Yeah, it's in the data. Yeah. So if it says between midnight and 6 a.m., there were some flights that left at midnight, which apparently here is 2400, not 00, which is wrong.
Some OLTP programmer should get shot over that. Like,
yeah,
this is where we go right back to OLTP and say, what are you guys, fucking monkeys back here? Come on.
Anyway, so that's I noticed that, and so that's probably accounts for that difference. Whoa. Ike. Yeah, Ike, you hip chat me when you've gotten things straightened out, if you can still hear me. And I'll unmute you on the TV there. Okay, cool. And then number 2, 83296. Okay. Oh, yeah, cool. All right, good. What happened there, man? That was weird. Uh-oh. Are you back? Hello? No, I unmuted it. I thought. Yeah, it's unmuted. Oh, there we go.
Can you hear me now?
Yeah, you're a little tinny, but yep.
Oh, sorry about that. I think it's USB-C's like octopus of connections to get a headset in. I just knocked it. Yeah, I knocked it. Yeah.
Okay, so I'm not understanding something. Summarize early. I don't know what I did there. It doesn't matter, I guess, though. Okay, so how many flights have a missing departure time? Yep, we got the same values there. Okay, this one I thought was interesting.
But wait, I think this is, you kind of glossed over something there, but I've noticed that for non-programmers, dealing with nulls is a little bit of a stumbling block usually for beginners. So I just wanted to talk about 3-value predicate logic and just make sure that everybody in the room understands the reason why null equality is weird in languages and why they have to define the rules.
Can you move your headset back just a little bit or something? Like, I feel like you're getting a little
too better?
Close to it. No, it's maybe just bandwidth issue. Okay, go ahead.
So does anybody have a question about dealing with nulls here, the way he's talking about them?
I mean, I think it's, as a programmer, it's different than how you do it in like a SQL dialect. You know what I mean? Like in programming, the only thing you have to watch out for is dereferencing them, right? You just need to check unless you're using a language like Objective-C or other languages that sort of deal with it for you. Then you have to check before you dereference something that is null. But in SQL dialects, like I notice you can't say equals null, or that's in T-SQL anyway. Like you'd have to say is null, right? It's very explicit when you're dealing with nulls or not applicable, I guess is what it is here.
Yeah.
I thought the book's explanation was pretty good
Yeah, me too.
with like NA basically like I don't know. Right?
Yeah.
So is I don't know true? I don't know, right? And then but certain mathematical things like you over there will be true for anything. Like anything raised to 0 is 1.
Yeah.
So it doesn't matter if I know it's going to be 1. Right?
Right. Yeah. Exactly. And then this one, you know, unknown or true is always true. I mean, false and something else is always false, right? And then this one was the tricky one that he mentioned, NA times 0. And the only thing that I could think of was he did call out infinity, positive infinity and negative infinity as other values that R understands. And if it happens to be infinity, then multiplying it by 0 is not a defined value. Whereas every other number on the planet, it's 0. So I guess it makes sense still for that reason. That was the explanation that I came up with. But right, exactly.
This is true,
right.
but you know, from the other side, 0 to the degree 0 is undefined in mathematics as well. And then it should be undefined. So
0 to the 0th power is 0.
0 to the 0th power is undefined in mathematics. It could be, you know, depending on what kind of things goes to 0, it could be different values.
So to put it simply, 0 to any power normally is 0, and anything to the 0 power is normally 1.
Yes.
So you get a contradiction if you try and apply both those rules to 0
Yeah,
and
this is
0.
I see.
It's either 0 or 1, but can't be both. So
Math is bullshit. Let's do something else.
Math is bullshit, Jim.
As a
Okay.
professional mathematician, I voice my disagreement.
So the so you're saying this one was also weird.
Yeah,
Yeah.
because, you know, it should be NA term from this point of view, because it could be 0.
I actually, for what it's worth, I thought all of these examples were kind of pushing things a little bit. Any operator with NA should just be NA.
Yeah.
And if you're doing something like an if statement, well then yes, you're doing, I don't know what the
logical operators
yeah,
or
so
whatever.
if
Yeah.
you say true or whatever, and
Yeah.
that has NAs, that's fine, because normally you don't even, once you hit true, you don't even evaluate
Yeah.
the
Yes.
second part, right?
Right.
That
Yeah.
I'm cool with. But if it's something like this, I think everything should just be NA. Shouldn't even bother trying to find these weird
So
things.
you're saying if it's written this way, false and or true or, then sure. But if it's written this way,
Yeah.
you would say that should be NA because
Yeah.
NA is encountered first, and so basically it should just be NA.
Well, again, because
Well,
you start getting these weird things of, well,
formulas.
why is it that way for or true, but not times 0, and should it or shouldn't it be to the 0 power? I mean, it's really weird if you're like saying, well, if it's to the second power, NA applies. If it's to the 0 power,
So it could be like, so I agree
Well,
that it
NA could be
either-
only true or false.
But you guys can't talk over each other because then we can't hear the conversation.
It will give you, you know, with R, it gives you,
I'm sorry.
it will give you, well, NA or true, it will give you true.
Mm-hmm.
And the second will be false, you know, when you use and. False and
Mhm.
something else. It will be always false.
Well, what Ted was saying was he can understand
Yes, I understand.
this being true because it'll short circuit.
But the formula, you know, is symmetric.
So from
Yeah.
like a pure math theory, like I'm sure you're right, but like another example like that is governed by like an IEEE standard is floating point number divided by 0, right? Like most people say, well, that's an exception, right? That's not correct. But the standard says it's positive infinity. So some of these things may be governed by underlying standards. And so that's, you know, again, you want to shoot the OLPP guy, you can go shoot the engineer who wrote the standard too. But that's why like the observed behavior may not be lining up with like what it should be mathematically, and why some of the symmetries may be broken just because there's a standard out there where someone made the call and that's the way it is.
Yeah, yeah. And it may not have been the correct call. Okay, so moving on to the arrange portion. This is before we had the pipe. And I was reacting to the fact that it was very inside out. Like I couldn't read it. You know what I mean? Like the data was flowing the wrong way. You had to start you had to figure out what set of parentheses was in the middle, and you had to start there and then work your way back to the left, right? And
Okay,
so
Scott, that's only because you don't use Excel all day or VBA, right?
No, it's a human thing, Ike, right?
Well,
it doesn't matter.
What they all do all day.
Not.
They write syntax like this all the time.
I know, but it's not as readable.
Well, but it is the correct order of operations, though.
Correct order of operations, sure, but it's just not as readable as I'm starting with the flights data. I'm now filtering it. I'm now arranging it, and now it's so
what
both more intuitive and easier to understand or read out loud. I mean,
that's true. All of that is true, and I'm not disagreeing with you. I 100% agree with you. The other side would be that in most applications, this method uses less memory because it operates in memory on one data set. And writing it out each time, going step by step, uses a lot more memory.
No, that's not necessarily true. In fact, the opposite can be true.
What? Oh, no, that's not true. If you are following the order of operations, then you get a
if you're using link
each time.
If you're using link, then the amount of memory consumed is the smallest amount of memory that it can consume. Yeah, so it's actually the opposite in some cases. So disagree. All right, see you. Bye, Russ.
Oh, we're losing Russ. Uh-oh.
Anyway, and it's so that's one of the things that I reacted in terms. I was like, oh God, I after using link and other things like this, where it's like this, then this, or even Unix pipe operators, I'm starting with this, and then I want to pipe it to that, and then I pipe it to that, and I pipe it to that. And it's just so logical, and it flows, and you can just read it and understand it very quickly. Like this, just the simple line here. It's hard. It's hard to figure out. You have to look at it for a good 10 seconds before your mind can parse it. Whereas if I wrote it the pipe way, I think that would be easier. Flight to change by descending. Oh, I guess that's still delay.
Okay, I think we need to pick up the pace a little bit because we're on page 50 something, and we need to. We're about halfway through, but we're an hour and a half in.
Yeah. Okay. Oh. Okay. Number 3. That was a good one. I don't know which page I'm on right now. No, fastest flights.
Page 51.
Yes, 51. Sort the flights to find the fastest flights.
So you need to divide distance by time.
Right. Okay. So it was the time portion that was tripping me up because I did this originally, and that was bizarre. I got all kinds of weird things. And then I did this one. To do this correctly, I said we really need what we're talking about is door to door, right? Time. Or are we talking about just in the air?
I thought about speed actually.
Yeah.
When I
So, you could just do
When I saw
speed.
this question, I thought about speed.
fastest.
Yeah, that's an interesting.
So
It's totally valid the way the question is written.
Yeah, either one could be.
Yeah.
Yeah. So for speed, you just used airtime.
there's a distance and airtime.
Yeah. Distance and airtime. That's what I meant. Yeah. So you didn't have to worry about this craziness. That was the craziness. It was not right. So I said, all right, I'll come back to it. And it just so happens that he came back to it later on. And like a couple of sets of exercises later, that he got back to it. And then he's talking about the ways to select. Those were 3 of mine, but there were more. Okay. Multiple variable names in a select call. It only does them once. One of does basically a distinct, which I thought was kind of interesting.
Yeah, when he showed that, I actually thought to myself, I think I like the one of verbiage a little better than distinct. But
Whoa, sorry. Where was that? Right there. Okay. So it turns out it's case insensitive, which for me, it didn't surprise me, but I don't know if anybody was actually surprised by the case insensitivity. Most databases, I feel like databases are kind of insensitive by default.
Except contains is more like a like.
Yeah, that's true.
Well,
Oh, and this was weird. This did not work for me. Hold on, if I comment that out and run this. Why is that? That was weird. I thought it must be just like a Jupyter Notebook dialect thing. So I actually can't do the case sensitive version.
Ted, why is that?
I don't know that one.
Yeah.
Okay.
I think it must be a Jupyter Notebook thing.
well, let me try it out.
So about here, by the way, when we're here in our studio, he introduces a shortcut called Control-Shift-P, which is resending the previous sent chunk to the console in the editor. That is a phenomenal shortcut.
Yeah, cool. Let's see.
Wait, can you do selected execution in Jupyter too? I guess you can.
No. Well, not really, because you're running a block, right?
Oh, you have to run the whole block. Okay.
Yeah. So I run. That's why I generally do each question its own block, even if it could be done, in the same, for that reason. Did it work for you, Jim?
I got love flights.
Oh, got it.
It's called flights.
Yep. Oh no, it's NYC Flights 13 or something like that. Dang it. I had it up here.
That's right. I'll find it. NYC flights 13.
Yeah. Okay. So currently departure time and scheduled departure time are not convenient. And so he talks about, basically a minutes since midnight type measurement. Oh, one thing I did like and I forgot about and then remembered again later was transmute, the combination of mutate and select basically as one thing.
Yep, I like that too.
Okay, yeah. Here we go. This is more of that craziness that I was talking about earlier related to arrival time and departure time and departure delay and whatever. Okay, so theoretically, airtime plus, wait, let's see. Hold on. Since midnight minus departure since midnight. Airtime plus arrival delay. I guess it would be time departure since midnight. I was messing with this, and I hope I didn't like mess it up. So maybe this is departure delay. Oops, delay. God dang it. Plus. Oh, okay, there it goes. So departure delay plus airtime plus arrival delay should be arrival time.
Obviously, you would call that total 1.
Yeah. Well, I just wanted to get the 2 columns next to one another because they are not at all in any way, shape, or form even slightly related to one another. Which means that this data set is a big ball of bullshit.
Well, I don't think it's fair to say that. It could be.
Arrival delay wrong there, Scott. Sorry.
Okay, go for it. I've done this like 30 times, so go for it. Whatever you can come up with.
Arrival delay is telling you a function of departure delay and airtime relative to scheduled airtime.
Okay, so don't include it.
Yeah, you're sort of double counting. Right?
Yeah. Okay, once again, these numbers are not even closely related. Or not even like I spent probably 4 hours on this particular one. I went through, sliced it, diced it, I was like, okay, maybe it's a time zone problem. The number of time zones that we're crossing, right? So let's take origin, let's take destination, look them up in the dictionary, find out the time zones.
Oh my God, Scott.
You know, like they just do not correlate. They're just, it's a bunch of crap.
But you're so delay is relative to schedule. That's not real time.
But even, it is a problem
Right?
with time zone. This difference should be
So-
always about 60.
Yeah, 60
120.
seconds exactly, or 60 minutes. Yeah, exactly.
Chris Burt online says, would you swap arrival time with departure time?
Arrival time with departure time. What do you mean?
Subtract the other way around. Departure minus arrival to arrival minus.
Okay. Get a negative number.
No, it should be positive.
Yeah, it doesn't make sense.
That doesn't make any sense. That'd be a negative number
Okay, well, I think it was worth experimenting.
People-
because it
Yeah.
is.
Yeah.
Yeah.
Where is it? Hold on.
Yeah,
Yes, it is
yeah.
positive.
But I don't know. Anyway,
But isn't the arrival minus departure more or less just the airtime without the delays?
you would think that would be the case, but that's not.
No, 'cause, I mean, you have the delay
It
tacked
is
on there.
kind of close. You see, 193 is about 180. So maybe people have different.
you would think.
Maybe they have different devices on this report. Maybe they, maybe they consider it different time, but
I
some
mean-
people think they are right when the plane touches the ground.
I mean, the only thing I could
Because
think of was it's like people were voting for time. Yeah, the time felt like 5 minutes to me. It felt like 6 hours to me. Okay, well, let's take the average. That was like a 3-hour delay.
But
Right?
Scott, if you enjoyed those 4 hours of trying to make these consistent, then I think you have a future in the data side of our business.
Yeah,
Because
no.
that's
I did.
basically
It made me mad, and so you know how I get like
Yeah,
if it's like a problem that I can't solve, it's like no, you're not doing this to me. I am the master of you, not the other way around. So it's like
I think people
Yeah,
have
what does it say?
different definitions,
Yeah.
for what it means for
different definitions of what the
at what point the
Well,
plane
no, I don't
arrived.
think that's the definition, but that's the right kind of concept. They're not the same because departure time and arrival time are not measured in minutes, but are numerical representations of the time. So if you're subtracting them, you need to base 60 because it's time.
No, he converted them to minutes.
no, I did. Yeah, I did that.
So-
we need to convert them to.
So I think the real answer, Scott, as someone who unfortunately travels more than I want to, is
the
that
time-
air
Hold on.
time is literally air time.
Yeah, minutes.
And all the time you go from the gate, taxiing, waiting in line to take off is
Yeah.
part of departure. It's not the delay though. That's just part of every flight.
Okay.
So you're saying the time that I spent on the runway is not considered either departure time or arrival time.
And it's not delay either.
It's not
It's
a
just
delay.
it's
Yeah.
normal, but it's not air time.
Got it. Okay. So that makes sense. So there's time in between departure delay and takeoff,
Yes.
and time between touchdown and arrival delay.
Yes.
So you're saying arrival delay is actually when I'm at the gate, but they haven't yet let me out.
But
or whatever.
sometimes total two is greater and sometimes it's less.
I know.
I-
Yeah, I
wa-
haven't
I-
played with the data, but I can tell you that like one of the most annoying things for me is I fly to Phoenix all the time, and it's an hour flight, give or take, right? And the first flight in the morning, every airline flying to every city wants to leave right around like between 6:30 and 7 a.m. So there's this huge line of planes waiting to take off, and so that flight is scheduled for an hour and 40 minutes because you almost always wind up just.
Actually, that's not every airport in every city. That is unique to San Diego. And the reason, yeah, San Diego has a unique problem with our downtown air silence, you know. So they do that in San Diego, and it's terrible because they say 6:30 departure, and they know it's going to be a 7:15 departure. They're just trying to get to the runway and get in line as quick as they possibly can to get that asset to its destination and in play as quick as they can.
But the thing that bothered me, as you're saying, is like it was sometimes greater and sometimes less than. Like
So there's no.
there was no rhyme or reason. Yeah.
Okay, we
And
gotta move on because it's 3:45 in the morning in London.
Because people write down the time and it is not, automated.
yeah, exactly. That's what I figured. It had to be some sort of human thing. These guys were spot on though. Like the schedule plus the delay, like that was legit.
Yeah, that was good. Okay, so what page are you on right now, Scott? Oh, we want to talk about piping.
Yes, piping. So that's summarize and pipe is that section. I can tell you once I get to the exercises, which are on 72.
Nice. Okay, that's some progress. Great.
That's some progress.
Yep. And just like you guys, when we got to the pipe, I was like, oh, thank God. This is
Yeah.
great.
Yeah, it enables you to just understand it a lot better. Okay. I don't know what I'm doing here. Was there a question on it? I thought that one was pretty straightforward.
Well, on page 73, it says, which carrier has the worst delays?
Oh, yeah. Which carrier has... Oh, wait. 73? Which question are you on?
Number 5.
Oh, number 5. Okay.
Yeah.
So hold on a minute. According to that, but I don't know why arrive delay would be in a... Yeah, this was bizarre. This is another weird thing about this data set. Why would arrived delay be in A, but arrived would be filled in?
Meaning it should either be 0 and not NA, or NA
Yeah.
equals 0.
Yeah, it should be 0, or it should be this row, which is depart delay and a canceled flight or a crashed flight. Actually, they didn't mention that, but technically a crashed flight also would not have arrived, or whatever.
That is a brutal observation.
No,
That's
sorry.
the whole time.
When you're looking at something for 4 hours, you analyze every possible nuance. I guess that's no
That's true.
matter how morbid. Yeah, exactly. Anyway, so
But I can tell you in the real world, the reason why it's NA is because some transactional systems won't give it to you. It'll come out ragged in the export. So you deal with it. I don't know if they're trying to emulate that in this data set, but in most data sets, you have to account for that.
Anyway, so that was bizarre that the proper way to determine if a row is has NAs, sorry, is to use the arrival delay as the column, because that is the one that has the most, if you look there, that's the one that is most likely to have an NA, and it's the determination for the row. And
you do that in most data sets because it sucks when the export comes out ragged. It just like, oh, these in this row, I don't have values for the last 4 columns, so I'm just going to leave them off. In fact, I'll even leave off the delimiter. I'll leave everything off, right? And so you're like, which of these columns is most likely to be missing is almost always the last one, whatever the last one is. So that's the one you end up testing, right?
Yeah. It's a little bit weird here because it was the penultimate column, not the, anyway. So you're asking which carrier has the worst delays? Frontier, AirTran, and Atlantic Southeast were the answers that I got. I don't know if anybody's mileage may vary. Your mileage may vary. That was funny.
I guess we've lost our sponsorship from those airlines.
Yeah.
Discrimination.
Yeah.
Yeah.
For each
but this
plane.
is a famous this problem is a famous BI problem that they've used a lot, and they use it in an example for KPIs. British Airways was getting hammered on revenue, and the CEO of British Airways said that he felt that revenue was a lagging indicator and that delayed flights were a leading indicator. And so he put the number of delayed flights on every single screen of every application that his employees used. And he did it based on the tier. So if I was a gate agent, I would see the number of delayed flights for the gates I was in charge of. And if I were a baggage handler, I'd see the number of delayed flights for the baggage system that I was leading, right? And if I were like a regional manager, I'd see my delayed flights. And if that number turned red, meaning your number of delayed flights became higher than the CEO had allotted to you, he would call you. You would get a call from the CEO asking what's going on down there, right? So it made that he basically put his entire organization on the same page looking at delayed flights, and he brought British Airways down to be the leader in having the fewest delayed flights in the business. And guess what happened to the revenue? The revenue shot up, right? So they used this example because he said it in a keynote at a data conference. It's in like every data book.
Sorry, while you're talking there, I was just trying to, there was a weird one here. I don't remember where it is now. Hold on.
I thought it was interesting, though, the one that it said, can you disentangle the effects of bad airport versus bad carriers?
Yeah, that was interesting. Yeah, and it was tough. That was not an easy one to do. There. This is the one I want to do. Which is this? Number 6. Number 6. Yeah. So here is mine over here. And here is this one. And I think that mine is right and that his is wrong because he didn't arrange by time hour. Yeah, count the number of flights before the first delay of greater than 1 hour. And if you don't arrange them by time hour, in other words, the time that they took off, they get a weird order and you're counting more or less than you should be, right? Anyway, so it was mostly correct, but there were some differences, and I think it's because of this line here. He didn't sort, which I don't know, maybe the ID. I mean, it was laid out that way, but I noticed when I was looking at the data prior, I would like run it and look at the data, and then add the next thing, and run it and look at the data and add the next thing, which is one of the reasons I love the pipe. That was great benefit for debugging. And I noticed that it was like, oh, that's out of order. And so I put that arrange in there. And then, that's how I came up with the difference. All right.
Got it.
Okay.
So the next chapter, or unless you wanted to keep, okay, so the next chapter is workflow scripts. And he finally, now we're all the way up to page 78, and they say in RStudio, Control Enter is selected execution for the line you're on. And I was like, oh my God, like I should,
And that's what Russ said. Russ said at the very beginning, he said, I can't believe that they told us that, at the end of, chapter 5 or whatever, rather than like the very first thing,
Yeah. Yeah.
We definitely want. Yeah. Cheat sheet would have helped.
I guess I kind of read everything and then went back and started doing exercises. So
yeah, that helped.
yeah.
And I was in Notebook, so I didn't have the benefit or the hindrance there, depending on your point of view.
So then chapter 5, I don't know that we have to talk about scripts. I mean, it doesn't.
Oh yeah, probably not. But I did want to mention one thing here.
The RStudio tips Twitter
back
account.
to the table of useful mutate and filtering functions. Did anybody find that table of useful mutate and filtering functions? Because I didn't. I was like, refer back to that table. I'm like, oh, that would be an interesting table. Where is that table?
I thought that was that whole chapter. Flyers.
Is it?
I mean, to me, that's like that's what the I don't know. Maybe that's the maybe not.
I see useful summary, but I don't know.
Say that, refer back to.
Well, that's the exercises on page 75.
So there's a list on page 56 and 7. I don't know if that's what he's talking
The creation functions.
Yeah.
Oh yes. So go this way. That's the easiest way. But make sure you leave it's like out here. Make sure you leave the door open when you leave, so you can get back in. I think that one. Just right out there, and you'll see it kind of straight ahead as you go out.
Is anyone by chance going through Encinitas on the way home?
Prop it open. Sorry. Okay. Sorry. Bathroom question. All right. So, which probably we should have mentioned at the beginning. Okay. So yeah, going on to the final chapter. Is that where we want to go, Ike?
Well, you're talking about chapter 5, right? The exploratory data analysis.
Yes.
So I actually think chapter 6 is like nobody cares. I mean, it's just all projects, which it wasn't that complicated. But yeah.
But, Russ's comment was that should have been the intro.
Yeah.
Like the control enter and the fact that you can, do these scripts and so forth. That should have been like first and foremost thing that was mentioned.
Yeah. So in chapter 5, he says EDA is short for exploratory data analysis, which angered me because EDA in data is universally known in data engineering as enterprise data architecture. And it's like the most important word in data engineering. They say it all the time, and then all of a sudden they're going to shift meanings for the science aspect of data. And I'm like, oh God, making both acronyms now useless. But
yeah, but maybe his came first.
Yeah, maybe. I don't know. Enterprise data architecture has been the acronym for like a decade, but whatever. Yeah, maybe.
If they hadn't done that, it would have been something like ADISIS.
Yeah. Extasius.
Yeah.
Let's see.
Exactly.
Yeah.
Pronounced
screwdriver. I don't know that any of this was surprising or.
Well, on 82, he quoted somebody and he says, Sir David Cox says that there are no routine statistical questions, only questionable statistical routines.
Yeah.
And something about that statement really appealed to me, so I copied it and tweeted it. And it wasn't very popular. Nobody nobody liked that tweet. I'm like, oh, I like that. I don't know, maybe, I don't know why it resonated with me, but maybe it's because I spend so much of my life doing data preparation, but.
So the price thing I thought was kind of interesting, where that was like the first part of the diamonds that I actually was like, oh, that's kind of interesting.
Because you had to buy one, is that?
No, it's
I'm
been
just
a
kidding.
long time since I bought a diamond.
Chantal's a lucky woman.
Yeah.
You got that ring. That was it.
Yeah. Well, she said yes. That was the last diamond I ever bought.
Yeah, indeed.
Oh my
So
God.
1,500 is there are no diamonds at that price,
Yeah.
which was weird.
Scott's like, what's the lowest price? Scott.
Yeah, you could introduce
But
No.
it is a raw diamond. It is not a real.
Yeah, not a real.
It's the raw. It's a cut diamond.
They're cut.
Yeah,
they're
yeah, it's
cut.
been cut. Yeah, it's just may not have been mounted. Yeah, in a ring or earring or whatever.
before the $1,500 diamond market then.
Yeah, exactly.
But they
Yeah.
overpriced.
All of them are, yeah. So, and this was interesting too. Yeah, like let's talk about, selling to your market. Like number of diamonds at 0.98. I don't know.
Yeah.
Yeah. Number of diamonds at 0.99. 2. Number of diamonds at 1. Oh, 1,600.
Yeah, I love that.
Yeah. Yeah, exactly.
So is the answer to that question that there's like some industry regulation that says you can't call it a 1 carat diamond if it's 0.99?
Well, no, I mean, it's just weight. Yeah. Measure of weight.
And they give you the exact weight. They like I have recently bought a diamond.
Yes.
Yeah, they probably cannot get away with rounding up.
No. Yeah, there are what is it? There's 4 or 5 different certification
rules, yeah.
certifications or whatever that. So it's like, hook me up. You did it recently, like GIS and whatever, and GIA, whatever. And so they basically audit you and make sure that all of your diamonds are properly measured and whatever. Or you send the diamonds there and they give you back the measurements.
But I'm saying there's nothing wrong with somebody certifying you have a 0.99.
No.
I mean, but the problem is if you just go and you say, I want a 1 carat diamond, then they can't show it to you, right? Because
No, they could.
Well,
They could.
I think the thing is this is indicating market desire.
Yeah.
So some guy, junior diamond cutter, shaved off too much off of that 1 carat.
Right.
So the diamond exists, but he's now been fired and is no longer producing 0.99 carats, right?
Because
Or he was severely beaten and now he knows how to make a 1 carat.
Yeah.
Well, in talking about like diamond weight, I kind of wished I'd married like a one-eyed woman who had no depth perception, because then I could tell her it was a 5 carat. Or like,
they talk about that, the Z,
yeah.
the depth or whatever. Like, where was that one? I don't remember where that was. But if you look at the X and Y, they're pretty close, and then the Z varied like crazily, and it was never in proportion to the X and Y, right? Like it was, there were very few, what do they call them? Ideal, cut or whatever.
Well, and because this is going to be on YouTube and there for all time and eternity, I would like to formally say that I'm very grateful that Margot has 2 eyes.
Thank you, Ike. We wouldn't have got it otherwise.
Yeah.
So another interesting part I thought was when he was talking about the X limb versus Y limb and the zooming via the Cartesian. That was I don't know where I put it here, but oh crap. Oh, did I like trim it? Must have trimmed it. Yeah, crap. Sorry. Anyway, so I thought that was interesting because the X limb and the Y limb basically culled the data set before drawing the graph. And the Cartesian zoomed in on whatever data set you had. Wait, no, I had to have it because I saw that bar. Yeah, right here. Yeah. So here I zoomed in on a graph that I already had, and I ended up zooming into a bar, basically. So this was like completely useless because my bar size didn't adjust. I just zoomed into the one that I had, and I was basically looking at a single bar, which I thought was kind of interesting. So
Yeah.
I felt like XLim and YLim were generally the better ways to go, right? Like they generally gave you what you wanted, but you have to remember that they're exclusive. They cut off.
Mm.
Yeah. So I had a question,
Yeah.
and I didn't get a chance. I didn't have time to play around, but I noticed that
Ted has a
Okay.
question. We're
Yeah.
dead.
I do
Oh,
have a
crap.
question. Yeah. So like if you were bucketing it in like 0.5 increments, then it would do like negative 0.25 to 0.25, and then 0.25 to 0.75. And I was like, every Excel chart I've ever done is 0 to 0.5, 0.5 to 1. And
Yeah.
1. So I don't know if there's an easy way to tell it.
You know what? I would consult my cheat sheet.
Yeah. See?
Like you're talking about
yeah.
seed value, right, Ted?
I think
Like,
that's the darn cheat.
can't you seed it correctly?
And this would be a
Beyond history.
histogram. Yes, thank you.
That, what was it? Cut. Then
Yeah, there's a bin width and then like
I don't know if there's like an offset or
Yeah.
something.
But that's kind of how I remember it from stats class, was that it would be rounded, not Excel style.
Yeah, I mean,
Chris, that was a long time ago.
yeah. So I was gonna play around.
Bin
but I
width,
remember I was on a
X,
plane or
Y,
something.
alpha, color, line type. Nope, size. Wait, I don't know. It's not on the cheat sheet, so it is a
All right.
valid research question.
Yeah, I think we're gonna have to see who can answer that first on the meetup discussion.
Yeah.
Shocking that nobody can answer Ted's question.
Yeah. Okay. I don't know. Would anybody else have any other questions that they want to cover? I don't know. I feel like I've been.
No, I think that's a
Maybe.
good thing to ask, because when you get here and he's building on things that we've talked about before, it did get, a lot of these questions did build on information we already knew. But
Yeah.
I will say, just in case anybody's new to visualization, that
yeah.
if you can explain a box plot, and not the box plots that they were creating on like 104, but a real good box plot showing a real good distribution that is somewhat equitable, that C-level people really like them, because you can show them the demographic of whatever they're looking at, their customers or their employees or anything like that, and they can really gain a lot of insight on their business, right? Like if you look at, like, give me a box plot on the average age of our customer. I did that recently for the RV industry, and it turns out in RVs, the average age is going up. It was 59 in 2010, and it's 64 in 2018, right? I'm sure that there's some commentary on the American dream there that escapes me, but you can what a box plot does is it shows you the mean, the median, and the inner quartile range of who your customers or whatever demographic you are, and it's a very good thing at visualizing it.
Yeah. So the box plot was good. I also liked, this one was interesting, the LV, but I don't know why, but it looked a little pixelated on my, it looks like, yeah, stay off my juniper bushes. But this one was awesome, I felt.
Yeah.
The violin. Yeah, that was really cool. Like, I felt that visualization showed it better than all of the preceding visualizations, both in the chapter and in the exercises. Like,
for diamond data in particular, it shows very well, doesn't it?
yeah, I guess, yeah, it depends on the data, but I thought that did a really good job.
So our story here is because it's price versus cut, that there was some fairly cut huge diamond,
Yeah.
right?
Yeah. See, look how the top edge of that
Yeah.
fair,
Well,
goes up for a lot longer,
In all
whereas
cases, there's a small number of huge diamonds for any type of cut.
yeah, exactly. So that's why the price was like that. Why the fairs?
Doesn't that seem to indicate that for ideal, it's mostly very low price ones?
Yeah, small diamonds are cut ideal. No one can afford the large ideal cuts, basically.
So size is not-
Yeah, size was still the best indication. Hold on, I got that here somewhere. Yeah, there. Carat, right? The weight. Oh, and one of the things I noticed here, yeah, this is one of those carat and price, and the number of plots was like, it looked like ink had spilled on the graph or whatever. It was like, just solid black. And so I just took like 20% of them, and it.
Decrease the size.
And you could decrease the size of the dot, right? But I just took like 20% of them, and it clearly showed it just as well as it had in the whole data set, right? It was an overabundance of data there.
You can use transparency.
Yeah, but I noticed that I'm not sure if you heard this earlier, but on the notebooks, like if you have these giant plots or whatever, it ends up consuming a lot of memory, and it slows the whole thing down. So
That's true. It's especially bad for ARM.
in fact, he talks about that in that was one of the reasons why he recommended this other package, this LV plot, which, by the way, the GitHub instructions are actually wrong. The GitHub install instructions were LV plot Hadley, but it's actually Hadley LV plot. So keep that in mind if you haven't yet done it but are planning to do it. But see, look how these
If only
guys.
GitHub had a way of correcting it, publishing.
Yeah. Well, okay. You're saying I should have forked his README?
Probably.
There is a function which cleans our memory from some reminders, and it is GC with parentheses.
Garbage collect. That makes sense. Anyway, this version, this LV plot version, basically the dots here, it does something so that it keeps track of which ones have been visualized thus far, and it basically culls the amount of memory that it needs. Yeah, cool. All right.
By the way, somebody went on Twitter and liked my tweet that I complained nobody liked. Just so I appreciate that.
That was me, Ike.
But yes, each plot actually duplicates the data which you use.
Yeah. Well,
It contains all the data inside of it. So
Yeah.
it's a duplication.
Yes. Yeah. And this one in particular, right? Or I guess not. I guess it's splitting based on cut. Yeah.
Yeah, I like that too. Facet Grid on that. Okay, so I think we're about done.
Yeah.
I
it
think
can be done.
if we're going to talk about what we're going to do next, we're actually going to do part 2 Wrangle. And part 2 Wrangle starts on about page 119, and it goes all the way to 250. Well, that might be a lot for March. I don't know. What do you guys think?
We had written down earlier through 222, through chapter 11. So Tibble, Reader, Tidier, again, Deployer, I don't know why.
Relational data with Deployer. So
Yeah.
joining, right?
Joining, yeah. And then Stringer. So just that. And then we'll talk about the last two
With program.
forecats, dates and times, etc. And then the programming aspects next time.
All right, let's do that. So what we're saying right now is that this month we're going to read chapter 7 through 11 through page 222. Sound like a good deal, guys?
Yeah.
All right, good.
All
I
right.
like this meeting. I enjoyed. It was worth waking up at 1:30 in the morning for
All right.
Can I make one comment?
Yeah, go for it.
The difficulty you were having with that bad data set, and clearly was a bad data set. I'm taking the data mining certificate at UCSD, and the class I'm taking right now is called data preparation. So there's a whole class just on data preparation. And one of the things they mentioned in it is that data scientists in their actual workday spend somewhere between 60 and 80% of their time doing data preparation, dealing with bad data. What do they do with the ragged data, the nulls? How do you treat that sparse data? So in case anyone thinks being a data scientist is glamorous, it's mostly that kind of grunt work.
Yeah. Yep. I've heard that from other people as well. And Ike probably has a personal experience.
Well, I
doing
spend a lot of my time. So the workflow is like this, where a data scientist will prepare data in R, which is notoriously slow for data preparation. And they'll be frustrated once they've matured their process that they have to do the same thing all the time and it takes too long. And so they'll basically hand you what they're doing, which is not really the R script, but basically, this is what's wrong with this data that I have to clean every time. And then we'll do that in the back end in data engineering. I guess Karcher's not there. Is Karcher there?
Nope.
Yeah, he was going to show up, but I guess he didn't come today. So what we'll do is we'll translate that into either like a Hadoop script, like or T-SQL or SSIS or Informatica or something like that, and we'll clean it in flight, and then we'll give them a cleaner, maybe not a perfectly clean version, but at least a version that takes a lot less time. So they'll spend a lot of time in preparation while they're learning, and then once they've learned, they'll ask us to automate it.
Floor 5. All right. Cool. Any other questions, comments, complaints?
Nothing online. Everybody online's good.
I think if we survive the first 5, 6 chapters, whatever, I think this next chunk is going to be a lot easier.
Yeah,
Okay.
I think so too. I think you're right.
I mean, I don't know. It looked like, I mean, I kind of, when we were doing at least the flights data, you know, I kind of got into that data because it pertained more to, you know, something that I
Cared about.
Yeah, cared about, exactly. And when we start doing, I don't know, like the programming stuff, I don't know that I will care. I know I do it for a living, but like, you know, it's, I've kind of like.
Okay, let's not leave on a downer note, Scott. Scott, motivate them to read. Let's not.
Okay, sorry. But I think once we get into the portions that talk about, you know, syntax and so forth, I think we may be able to read more, is my point. Like faster, go through it rather than the exercises that are requiring like in-depth analysis and like, oh, how do I, you know, plumb through the documentation to find the, you know, esoteric little command that, you know, lets me do what he's trying to get me to do.
So I mean, I guess it's just going to depend on the will of a group, right? Because, right, you know, some of us know what if statements are, some of us might not.
Yeah.
But definitely back, like when we get to part 4 of the model, like to me, I'm like interested in seeing like, how do you persist one of these things? How do you make it operational, right? So scientists has already created the model. How do I go out and like put that in a Docker container, run it on batch, right? So
yeah.
One of the things I'm hoping to get, which is pretty late in the book, and I can only study it myself. But,
Yeah. No. I think so. Our plan, when we talked originally, we may modify this depending on what people want, but our plan was through 116 through 222. The next one is 2 through 344 because again, it has a lot of that, you know, programming commands that a lot of us are familiar with, and it's not as much analysis. It's more like being able to ingest, you know, the syntax and how things, you know, the nuts and bolts, I guess. And then
Basically the rest of
Part
it.
4 and part 5. Yeah, the rest of it.
Yeah. So we'll get there quick, Jim.
Quick.
All right,
But-
guys, I'm going to try to get more sleep before I have to speak to the rest of the world at noon today.
All right. Take care, Ike.
All right, thanks, guys. Have a good night. Yep, thanks, guys. Yep.